In today's lecture, we are going to learn what fundamental theory of arithmetic is, and coefficients relating them. Okay, so what the theorem says is that every composite number can be expressed as a product of primes and this factorization is unique apart from the order in which the prime factors occur. For example, let's take 72. So the prime factorization of 72 will be 2, 36, 2, 18, 2, 6, 2, 3, 2 9s are 18, 3 3s are 9, 3 1s are 3. So this is 2 cube into 3 square. The same thing we can write as 3 square into 2 cube. So the order is not important. What is important is that it has 3 factors of 2 and 2 factors of 3. So 72 cannot be expressed in any other numbers, as this is the product of primes. You cannot show it in terms of any other primes, and this is unique apart from the order. Order means if you place 3 first and then you write 2, so it means the same thing. So order is not important. What is important is that the prime numbers are unique and their powers will also be unique. Okay, so let's deal with the quotient. Consider the numbers 4 to the power n, where n is a natural number. Check whether there is any value of n for which 4 to the power n ends with the digit 0. Solution. First of all, given to us is 4 to the power n, which becomes 2 square whole to the power n, and whenever powers are inside and outside brackets in this way, powers get multiplied. So this is 2 to the power 2n. So if the number 4 to the power n for any n belongs to natural number were to end with the digit 0, then it would be divisible by 5, because we know that any number which ends in 0 is a multiple of 10, and any multiple of 10 will definitely be divisible by 5. This means that if 4 to the power ends with 0, means it should be divisible by 5, and if it is divisible by 5, so in the prime factorization of 4 to the power n, there should be a number 5. This means that the prime factorization of 4 to the power n would contain the prime 5. This is not possible Why is it not possible? Because we saw that 4 to the power n on prime factorizing, that is only in terms of prime numbers, it has only number 2 as the prime number. So this is not possible because the only prime in the prime factorization of 4 to the power n is 2. So, by the uniqueness of fundamental theorem of arithmetic, as we saw that fundamental of theorem of arithmetic says that every composite number can be expressed as a product of primes, and this factorization is unique. So by the uniqueness of fundamental theorem of arithmetic, there are no other primes in the prime factorization of 4 to the power n. So there is no natural number n for which 4 to the power n ends with the digit 0. You can also write the statements on your own, but make sure you ask me to check them because the statements are very crucial. If you miss any line, then you may not be awarded full marks. Next question. Let's say find the LCM and HCF of 6 and 20 by prime factorization method. Okay, so first of all we'll write the prime factorization of 6 and 20. For 6 this is 2 into 3, 3 ones are, and for 20 to 10 to 5, 5 ones are. So 6 is 2 into 3 and 20 is 2 square into 5. Now HCF of 6 and 20, HCF is the highest common factor. So the common factor first is 2. So there is only one 2 that is common and there is no other common factor. So HCF of 6 and 20 is 2. And LCM of 6 and 20 will be, first of all, what was common over here, HCF, we'll write the HCF, and after writing the HCF, whatever is remaining, we'll write them. Now, only 1 2 came common, so we have 1 2 left over here. We have a 3 and we have a 5. So this becomes 2 to the 4, 4 3 12, 12 5 60. So we have 60 as the LCM. So this is how we find the HCF and LCM by prime factorization method. Now, as we note over here that if we multiply HCF of 6 and 20 by the LCM of 6 and 20, we get 2 into 60, which is equals to 120. And if we multiply these two numbers, 6 into 20, again we get 120. So by this we conclude that for A comma B belonging to natural number, the HCF of A comma B into the LCM of A comma B will be equal to the product of two numbers. This is our first no. At the same time, we also need to remember that for A comma B comma C belonging to natural number, HCF of A comma B comma C into LCM of A comma B comma C is not equals to A into B into C. For three numbers, this is not true. We'll just write another word, all. So for all A comma B belonging to natural number, this is true. For all, for you take any two natural numbers A comma B, this will always hold true. But for A comma B comma C, not for all it will hold true. For some it may hold true, but not in all case. So let's deal with some questions relating the same. Find the HCF of 96 and 404 by prime factorization method. Hence, find the LCM. Solution. Remember this one, for three numbers this will not hold true for all in all cases. Okay, so we are taking 96 and 404. Let's find their prime factorization first. 96, 2, 4, 8, 8 is 16, 2 2 is 4, 2 12, 2 6, 2 3 is 3 1 is 404. 2 2 is 4, 0, 2, 2 1, 0, 1. 101 will be divisible by this is not divisible by 3 as the sum is 2, will not be divisible by 5, will not be divisible by 7 as well, is not divisible by 11. Let's check by 13. No, it will not be divisible by 13 as well. Then 17. 17 5s are 85, no, not divisible by 17 as well. So this is not divisible by any number before this one. This will be a prime number. So 96 is 2, 1, 2, 3, 4, 5, 2 to the power 5 into 3, and 404 is 2 square into 101. So we need to find the LCM, HCF using the prime factorization method. So HCF will become, what is common in this is 2 square is common in both of them, and no other digit is common. So HCF is 2 square, which is equals to 4. And we know that HCF of 96, 404, this is our rough work, we'll write this inside, into LCM of 96, 404 will be equals to 96 into 404. The HCF into LCM of two integers, positive integers, is equals to their product. So which implies LCM of 96, 404 is equals to 96 into 404 by HCF of 96, 404. So from here we get 96 into 404 divided by 4. 96 into 404 divided by 4. 4 ones are 101. So 96 into 101, this is 96, cross cross 96. So 9696. So we get 9696 as the LCM. Next question. Find the HCF and LCM of 6, 72 and 120 using the prime factorization method. Okay, you may get sometimes confused that I write Z in factorization, and in book there is written S. Both are correct. Z is in English, Britain English, and S is in American English. You can write both of them. Any one would be correct. So solution. First of all, 6 is 2 into 3. 72 would be 2, 36, 2, 18, 2, 9, 3, 3, 3, 1, and 120, 2, 6, 2, 3, 2, 15, 3, 5, 5, 1. 72 is 2 cube into 3 square, and 120 is 2 cube into 3 into 5. So HCF of 6, 72, 120. What is common in all three? 1, 2 is common in all of them, and we have 1, 3 common in all of them. So we get HCF as 6. And for LCM, we have the highest power of 2 in all of these 3 is 2 cube. The highest power of 3 in all of this is 3 square. We'll check in the same way for all the different primes. The highest power of 5 is 1. So if there would have been 7 over here, we would have multiplied by 7 as well. So this is equals to 2 cube is 8, 9 into 5. So 8 5 is a 40, 40 into 9, 9 4 36. We get 360 as our LCM. So let's check this. So HCF, this is just checking, okay, this is not the part of your solution. Our solution has been ended over here itself. So HCF of 6, 72 into 120 into LCM of 6, 72, 120, we get this as 6 into 360, which is 6 into 6 is 36, 6 3 is 18 plus 3, 2160, and 6 into 72 into 120 will become 72 into 6, okay, 6 to 12, 616 plus 1, 72, 72 into 720, so 72 into 72, let's do it over here in the corner, 72 into 72, 2 to the 4, 7 2, 14, 7 to 14, 7 7 49 plus 1, 50, so 5184. Clearly, as we can see, HCF of A, B, C into LCM of A, B, C when we take three integers is not equals to A into B into C for all A, B, C belonging to natural number. It may be true for some of them, but this is not true for all. With this, we come to the end of this lecture. Thank you.